Exercise 12.2 Problem 5 Discussion. One number is chosen randomly from the integers 1 to 50. Find the probability that it is divisible by 4 or 6. So you have to understand, in the exercise 12.1 they used to ask us find the probability that it is divisible by 4, or second part will be divisible by 6. But here they are combining it together. That is the key difference you shall have to notice. So whenever this OR comes, earlier this will be division 1 and division 2, two problems, right? Now they have combined it together. So when they say 4 or 6 means, this is if we define this divisible by 4 is event A and divisible by 6 is event B, what we are asked to find is probability of A or B, which is probability of A union B. Then you have to use that addition theorem of probability, that is probability of A union B is probability of A plus probability of B minus probability of A intersection B. So we need to calculate probability of getting 4, probability of getting 6, and then probability of getting a number which is divisible both by 4 and 6. That is also possible, right? For example, if you happen to select 24, 24 is divisible by 4 as well as 6. Similarly, if you select 36, it is divisible by 4 and 6. That is, those events are all pertaining to A intersection B. Okay, so we have to basically keep in the mind that this is using the probability theorem, right, or addition theorem. And okay, what is given? The numbers are from 1 to 50, right? And you have to first list out the sample space, then list out event A, and list out the elements of event B, list out the elements of A intersection B, find probability of A, probability of B, probability of A intersection B, and substitute those values in the addition theorem. Okay, let's get going. What is given? The given is the integers are numbered from 1 to 50, and your probability, we are asked to find probability of choosing a number which is divisible by 4 or 6. Okay. Now, the addition theorem is the one which will be applicable, right? So, let's put the steps. First step is list the sample space and find n of s. Okay. Next, let A be the event of getting a number which is divisible by 4 and B the event of getting a number which is divisible by 6. List the outcomes of A, B and A intersection, A and B, that is A intersection B together. Find n of A, n of B and n of A intersection B. Okay, so before going, first step is list out the sample space. Sample space is 1, 2, 3, 4 up to 50. Then you have to list out the outcomes of A. A is defined as divisible by 4. So select all the numbers which are divisible by 4. Similarly do for B. Then find A intersection B. Then find all their numbers. How many entries are there in the sets A, B and A intersection B. Thereafter, find their probabilities using the formula. Probability of A is n of A divided by n of S. Similarly, do for probability of B and probability of A intersection B. Once you know all these things, then you just need to substitute those values in this formula. Right? We know this, we have calculated this, we have calculated this, and we have calculated this, which means this can be calculated. Okay, so this is how this problem needs to be worked. Let's get going. I'll do the problem together with you. So, in choosing a number from integers 1 to 50, sample space is S equal to 1, 2, 3 up to 49, 50. Right, so these are all the numbers. So, for 50 ways you can select a number. So, the sample space is a collection of all the outcomes. So, the outcome can be 1, outcome can be 2, outcome can be 3. Any number between 1 and 50. So, there will be 50 outcomes. So, n of s is 50. Now, let A be the event of choosing a number divisible by 4. Right? So, divisible by 4 means you will have to select all the outcomes which are divisible by 4. So, that comes here. The outcomes are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. All these outcomes are divisible by 4. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes are there. So, n of A is 12. Probability of A is n of A divided by n of S. So, 12 divided by 50 is the probability of getting a number divisible by 4. Do the same for divisible by 6. List out all the elements which are divisible by 6. What are the elements? 6, 12, 18, 24, 30, 36, 42, 48. You can't go further than 48 because the next divisible number is 54, which is not in the sample space. 50 is the end point and 1 is the starting point. So you have to be very careful. Okay. So how many entries are there? 1, 2, 3, 4, 5, 6, 7, 8 entries are there. So probability of B is n of B divided by n of S, that is 8 by 50. Now you will have to find probability of A intersection B. So for that you have to find what are the outcomes which are common to both A and B. So as in the previous problem, let's go to set B, because there is no point going to the sample space and checking. You have 50 entries, but B has got less number of entries. Okay, I think it's got only 8 entries, right? So we'll have to select numbers which are divisible by both A and B. So you can go to this or this and select it, but this is also bigger than this, so we'll go to this set. So from this set, select the numbers which are divisible by both by 4 and 6. That is what A and B means, right? A is divisible by 4 and B is divisible by 6. So A and B means divisible by both 4 and 6. 4 and 6 is 12, 24, 36 and 48. So these are the 4 entries. So list the elements here. So A intersection B is 12, 24, 36 and 48. What is n of A intersection B? 1, 2, 3, 4. What is probability of A and n? So it is not union, it is intersection. Okay, probability of n intersection B is n of A intersection B divided by n of S. N of intersection B is 4. N of S, we know it is 50. So probability of n of B, probability of A intersection B is 4 by 50. Now substitute all these values in the addition theorem of probability. P of A is 12 by 50. P of B, okay, let's check it. P of A is 12 by 50, right? 12 by 50. P of B is 8 by 50, right? And minus P of A intersection B is 4 by 50. Substitute all these values. So 12 plus 8 and 20, 21 is 4, 16. So 16 by 50 or it is 8 by 25. Thus the probability of choosing a number which is divisible by 4 or 6 is 8 by 25. Okay, so let's recap. First thing, list out the sample space. Find n of S. Define event A as divisible by 4 and list out all the elements of A. Find n of A. Find probability of A, which is n of A divided by n of S. Do the same for event B. List out all the elements divisible by 6. Find n of B. Then find probability of B. Then go back to set B and find elements which are divisible by both 6 and 12. Sorry, 6 and 4 and 6. Because that's what A intersection B means, right? So then you get, list out all the elements. Find the element, a number of A intersection B. That is 4. Then find probability of A intersection B. So now you have all the three. Probability of A, probability of B and probability of A intersection B. Substitute in this formula on the right hand side and you'll get your left hand side, which is probability of A union B. But what is probability of A union B? Probability of choosing a number which is divisible by 4 or 6. A is divisible by 4, B is divisible by 6. So probability of A union B is probability of getting a number divisible by 4 or 6, and that is 8 by 25. Okay, so I hope I made it clear. If not, please go through one more time. It will become clear. Thanks for watching this video.